Um, you won't see this because we don't need this yet. So this weekend I did receive the preliminary copy of the exam. They made a few revisions, and then so I got the revised there. And first I have to apologize. I was a little wrong. There's two questions from 11.3. However, 11.3, right? Yeah. However, 11.3 is the product rule and the quotient rule, and those things it takes a little time. So I could teach them, but it's like this whole thing for really just one question. Because the other one, I'm going to show you how you can do it without the product rule. And then the other one that you need the quotient rule, I'm going to put something else there. So those 8 points will be something else. And what we'll do is we'll do 11.3 after the test so that we can just focus on we can be really successful with what we've built till today. Okay. And then we'll have the months, because it's not necessarily that the product rule or the quotient rule, if you've seen those before, they're not necessarily difficult, but there's something new. And to be learning all of this, I just, again, if they had more on the test, I would probably go that route. But there's only two, and one of them I'm going to show you how to bypass the product rule and just use what we've already learned. So basically, the test will, let's see, what did I tell you? Let's go here. So no, that's not the right one. Oh, exam review, yes. So here I tell you, in the exam review, this is the ones that's being provided. So they're a new review. The other thing is there is the exam review quiz. A lot of you already completed it because it was that one that had like a due date a couple weeks ago, or that we weren't really ready for. So a number of you completed it, got the 50 points. I moved the deadline, the due date for it, and actually I moved it till the day of the test. So it's based on the previous semesters, the last time I did this, and it's got a really good review. So I'm going to highlight that one. It's got a graphical review that you need. This one doesn't have that. So also, the things you need to do is take that quiz. I think I gave you 3 attempts, so you can go through. If you don't get all the points the first time, take a look at it. Do it a second time. If you don't get all the points, you've got a third time. Before you do it the third time, though, get some help and figure out what was wrong. Okay? Because I want you to, and you might get them all the first time. So the test is, 6 multiple choice. So there's a question. There are 5 answers. 4 of them are wrong and 1 of them are correct. Your job is to circle the correct one. You don't have to show your work. There are 3 true or false. That's on question number 7. And so there's a total of 9 points. And then there are 4 free response questions, some with multiple parts, and those are 61 points. So largest portion is free response. And all that means is they say find the derivative of this, basically show your work. There's one on find the equation of a tangent line. Okay, so there's a review and there's answers to the review. I don't think I looked at this. And what you'll see is in the answers, they do provide quite a bit of explanation. Okay. And so tonight we're going to take a look at a few of them together. See if you have any other questions, maybe over the homework and stuff, but no new material. Basically everything we've learned from last Thursday is all that we're going to need. Now we just need to finish up the homework, figure out how to do that, work through the review test. We got today, Thursday will be just a work session, answer questions if you've got, but it's kind of like nothing new, but let's practice. So that's, again, you've got all the answers here. Occasionally there's some that might be wrong, so if you come across something, let me know and I'll do a check. I think they've got 3 people working on the coordination team for this, and they tend to work pretty good together and check each other's work. I usually work by myself. I make my mistakes, and nobody finds my mistakes except my students. So we should be in pretty good shape that way. What I did this morning, let's see, where do I have it? I think Where is it? Is that it? No, that's not it. I think it is. Where did it go? To not the answers. Oh, exam review. So I went through the exam review. So I'll kind of highlight through here. I'm going to do one in particular, but let's see if they are here. Uh-oh. I thought it didn't save. Didn't save my highlights. So let me. A moment here, and it's not there. Well, oh, here we go. Thank goodness for file history. I think, oh, but it's, oh, okay, there it is. Okay, so what was my note here? Be able to find a limit for x going to a value. So they've got these ones for you to practice going to a particular value. I'm just letting you know on the test, instead of giving you a function, they give you a graph. Okay, so be able to from a graph figure out left bound, right bound, and the boundaries that way. Okay, so there's a question about that. But they didn't provide any of that. So that's why I wanted to do is they really should have provided one. If you go to the quiz, I think the first question they have redlined a graph. That's a good question because it asks the limit at like x equals 6. You just read it off the graph. That's the type of question they'll be. And if you can do that one, you can do the one on the test. Okay, it's a pretty simple graph. So that one. I've checked these ones. These are the types you should know how to do, and we're going to infinity. What is the thing? And this, we'll just kind of do a quick review type thing. What is the thing we need to worry about with these three different ones? All going to infinity. There's only two terms we have to worry about. What are they? Very good. Ignore everything else, sort of do the canceling out, and then you're able to kind of say, well, if I plug infinity, where's it going to go? So if the powers are the same, that all goes away, and so it goes to these coefficients. This would be just really 3 over negative 13, right? If the biggest one is in the bottom, right, there'll be an x left in the bottom, let that go to infinity, this thing's going to go to 0, right? And then this one, if the bigger one is in the top, when they cancel out, it's going to go to infinity, which means it goes to infinity. Okay, so just know those are the three cases that can happen. And all we have to do when we're considering x going to infinity is look at the biggest terms. Okay, so not on the multiple choice. If it is a free response, and I won't give you that much detail because I can't really remember, but all you would have to show is maybe that this becomes 3 over 13 and cancels, and then, so it just because you have to show work doesn't mean it has to be voluminous work. You don't have to explain, but just show me sort of what you did. Even if you just circled these, it shows me, okay, that means you're ignoring everything else. So that it could be simple work, okay? But again, on multiple choice, all I'm going to do is check the answers. If you do show work, it does give us something to talk about later on that, maybe some partial credit or full credit. Yes. Right, because so the bigger one down here, everything's going to cancel. We're going to have an X in the bottom, so this will go to zero. The bigger on the top, infinity, nothing to bound it. Yes, good. Okay, so again, practice, and there's a few others to practice like that. Um, and again, multiple ones, but that's all do them all. They should be pretty quick and forward. That's all there is to it. Just look at the largest, and then it's the ratio of the top to the bottom. Um, these are good ones to work again, but what I did is I chose ones specifically that definitely do these. I would also do 8 and 9, but I would do these highlighted ones first. Make sure you understand them. Those are the important ones, and the other ones are kind of supporting that. If you understand this, those will be okay, but make sure you understand these ones that I've marked. Okay, does that make sense? And again, we could take a look at this. We've got two functions based on percentage points. They want us to compute a limit as it goes to infinity, then interpret the results. So what's going to happen as this first one goes to infinity? What's that? Well, if t squared, if you take infinity and you square it, what do you end up with? Bigger infinity, huh? Yeah. So it's going to go to infinity. So the results are, and then on these ones, they might be multiple choice. So what is the result? Well, what does it mean? T goes to infinity, W goes, so the percentage points will go to infinity. Popularity of Twitter and LinkedIn. So if their popularity goes to infinity, what does that mean? They're as popular as can be, I guess. That's their popularity goes to infinity. So it's a matter of saying where does it go, and then connecting what does that mean? What is the output, right? T goes in. So it means in some indefinite period in the future, they'll become so popular. Of course, that doesn't seem to have happened, but times change. And again, this one now, the top over the bottom, right? This is a different one. If it goes to infinity, how do we analyze that with W in the top, L in the bottom? It's going to, these will cancel out. We don't worry about this. It's going to be 0.33 over 0.4. So it's some set value, 33% divided by 0.4. And I can't do that in my head, but whatever that number is, that means that what's the result? The ratio of their popularity will go to whatever percent. Okay, so just kind of, it's more of a conceptual type question, but there is a little bit of calculation. So again, be able to engage with this one. And I want you can go back and review. We've had similar problems to these. And again, there's these ones up here are similar, but make sure you take a look at 10. There's going to be some rate of change type problems where they give you a table and they want you to calculate, use the data table to compute the average rate of change. Average rate of change, what is average rate of change? It's the slope of the tangent line. It's y2 minus y1 over x2 minus x1. It's the slope formula. So for this one, 91 to 99, so that's 1 and 9. We use these 2 points. We forget about everything in between. We find the slope between those 2 points. That's the average rate of change. Okay, it's not calculus yet, right? It's not the instantaneous rate of change. So be able to do that calculation using a table. Be able to do that calculation using a graph. Okay, this is, wait, what is this? Interpret this, oh, no, this is a different one. So given a graph, be able to talk about the sign of the derivative, right? So how could we describe this one? What is the slope doing? It's negative, and then so it goes from negative to positive. We could describe it that way. Again, this might be a multiple choice where they give you various options. Just read them carefully. You know, that's the description of that sign. So then graph this. We won't actually have you do that, but this is the main thing. Be able to look at a graph and be able to talk about the slope of the tangent lines, the direction of the derivative, the sign of the derivative. Okay, so the tangent line is going down, that's a negative slope. If it's going up, it's a positive slope. If it's horizontal, it's a zero slope. We okay so far? Okay, I think we had something similar to this one. We get a graph, some plants, calculate the average rate of change over an interval. Again, just like that other one, except not a table with a graph. So again, y2 minus y1 over x2 minus x1, just a slope function, right? Average rate of change. So know that one. These are good because there's a couple true and false in there. Well, actually, there's three true and false I've already told you. True and false are tricky because there's only two answers, and they don't want to make it too tricky, but they don't want to make it too obvious either, right? So, but that's what makes them tricky, is then you start guessing yourself and you think, this should be true, but are they tricking me? So that's what makes them hard. So during the weeks, the instantaneous rate of change of the population is increasing. So 4 to 12, again, this is talking instantaneous rate of change, not average rate of change. So we're going from 4 to 12. So we're looking at the slope of the tangent line, and what's happening to the tangent line? Is it getting steeper? No, it's getting shallower. It's not, so it's here, it's kind of steep, but notice it's not increasing. The slope is it's getting smaller. Yes. The function is increasing, but the instantaneous rate of change is not. The instantaneous rate of change is all those slopes. Those slopes are actually getting smaller. So that's a good question. So yes, this function is increasing, but the rate of change, the instantaneous rate of change, is not. Okay, so, and that's one of the themes throughout this whole course. We talk about the function, we talk about the derivative, and those are two separate things, and sometimes those answers are, different. That's the hardest part of this class, I think, is separating between when we use, but it's the most valuable part because, in your business decisions, sometimes you need to know value. What is the value doing? It's increasing, but it's decreasing, the rate's getting down, so it's at some time we're going to level off, and maybe we want to get out before it levels off, or that kind of thing. Good. So watch those. And again, you have the answer key, so kind of go through them. My suggestion is kind of go through these, especially I would say, do 5B. That's an important one to do. Not do the other ones, but do those first. See how you feel. And again, there's multiple parts here because true-false questions need practice because they're tricky. They always end up being tricky. Even if you don't try to make them tricky, they are. This is a good one. We've got a function. Interpret the meaning of the function value. So this is, since it's a function value, it's number of students taking the test, right? I think that is. What is this? This is a derivative. Notice it's just got a little mark, but that makes it different. What is a derivative? So what? Prediction of the next. So we could think of it as the marginal. It's the slope. It's the rate of change. It's not. This is not. Well, it is students, but it's students per whatever this per year something. So it's a prediction. So it's different. Even though they're both at year 16, we know this is much smaller, but it's predicting we're going to increase by that many students. Good. It's a prediction. This is a stated fact. That's how many students there were, according to the function. So kind of be able to go through those type of things. And again, some of them are a little wordy, but I think this is actually set up. Yeah, this is a multiple choice type question. And that's why I wanted you to be able to go through it, because there are a couple of multiple choice that are like this, that are wordy. And it's, even though you know what's happening, reading the right one can get time consuming and can be confusing at times. Okay, but what you want to do first before you start reading through all these is say, okay, what do these two things mean? Okay, now maybe I can start Yeah, students per year, student in every 16 years. Yeah, so then kind of figure out which one works. Um, Here, this is the one I want to work with you. This one we could use the product rule, and it's probably assumed that you would do that. What I'm going to show you is, can anyone tell me another way without using the product rule? Say we don't know the product rule. How could we do this one? What kind of, maybe we'd have to do some algebra first. Let's see. So what kind of algebra would we do? See if I can write on this thing. Um, see if this works. This one is kind of new, but it's not. Um, Let me go to blue. So what we're going to do is we are going to, well, if we can write, here we go. We are going to FOIL first, outer, inner, and last. If we FOIL it out, we get a polynomial that we've already been doing. Okay. What I want to do is this is sort of after we finish the test. This will be the type of question I'll start with, and we will do it with the product rule, and we'll see we get the same answer once we multiply it out. So negative 5x squared, and I'll just write this out, times x to the minus 2, right? So that's the first two being multiplied. And then first outer, I don't always do in order. So negative 5x times negative 7. A negative times a negative gives us a positive. And I'm just going to write it out as 5x squared times 7. And then I'll do it later. But this is what we're doing. Then we take the last term here, this 7x to the minus 1, and we multiply it by x to the minus 2. And that's a positive and a positive. So we get plus 7 x to the minus 1 times x to the minus 2. And then the last, 7 times 7, we've got a plus and a minus, so that's going to be a minus 7x to the minus 1 times 7. Okay, and then I'll clean it up a bit, negative 5. When you're multiplying two things with exponents, what do you do with those exponents? You add them. What is 2 plus negative 2? 0. That's nice, isn't it? What's x to the 0? Oh, beautiful. It's a constant. See, sometimes it eases it. So that's just negative 5. I could put x to the 0, but, you know. This is just 5x squared times 7. So 5 times 7 is 35. So that takes care of that piece and that piece. And so then we got 7x to the minus 1, x to the minus 2. Again, we add exponents. So that should give us plus 7x to the minus 3. And in this last one, negative 7 times 7. So that should be negative 49x to the minus 1. Now, with all that we've done so far, can you find the derivative of that? Yes, you can. And you don't need the product rule. You just need the sum rule, the difference rule, the power rule. But we've done all of these, right? It's simple. So there'll be a question like this. I'm going to leave it on because I'm not supposed to change it, but I am going to change one of them. I'll take that prerogative. If they want to fire me, they can fire me, but they won't because it won't get anyone else to work on this. So there is another one that are like this, and that's the one I'm going to change because this you really, what can we do with this? You need the quotient rule. We'll get that after the test, and you'll see another one of those on a later test. Okay, but it's like for that one question, should we spend a whole day learning about the product rule and the quotient rule and then forgetting about all this? No, I say not. I'd like you to start off with a really strong, confident beginning. We'll come back to this stuff. It'll seem easy when we get there. But right now, I just don't like that flow. So be able to FOIL, and then you'll have something that you can take as derivative, and you're going to be just fine with it. Okay. The one that's like this is going to get changed to something like one of these up above, which are just, they're already ready to go. I mean, this we could do the same thing, just distribute through. I won't give you one of those. There's not one like that. There's one like this, and there's one like this. Those are the only ones we need. So this will get changed into something that's very doable. Okay. Is that okay? Okay. So take a look at that one, practice it, and you'll be in good shape. Oops, let's delete this. Tangent lines know how to find the tangent line. So they'll give you a function. They'll give you not a point, but just an x coordinate, right? To turn this into a point, what do we need to do with this value of 1? Plug it in to the original function. That gives us a y value, so we've got a point x and y. How do we get the slope of the tangent line? Derivative, right? Derivative of the function, plug in 1, that's the slope. Okay, so plug it in first, we get the y value, so we got a point that it goes through. We've got a point, derivative will give us a slope. We put that together, y equals mx plus b. Okay, and we'll look at more of those, but practice those. There's several of these, and I just chose this one. Looked good. This one already gives you the point, so I wanted you to do one that's a little harder. This one will be a good practice too. They just give you the x, you have to find the y. Sometimes they give you the x and y. They were kind of nice. Don't have to plug it back in, but practice those. So know how to find the slope of the tangent line. If you come on Thursday, I'll show you if you've got a TI 84 or 83, there's actually a function, and I've already shown you. If you use the draw tangent line, it will actually give you the slope of the tangent line. So you get another way is you could plug it in. But if they want you to show your work, you have to kind of be able to find this. You should be able to do that. Okay. But it's a good way to check. Is a good problem. Again, what is average velocity? The velocity between two particular points, right? That's a secant line, right? So they give us two x values or two input values. We have to plug those in, get the y values, and then it's slope, y2 minus y1 over x2 minus x1. Instantaneous rate velocity, how do we get that? Derivative, because that's the slope of the tangent line. The only tool we have for that is calculus. Take its derivative, plug in the seconds, that gives us our instantaneous rate of change. So be able to know those two differences. When do we use the average rate of change? And again, they'll ask for it. Average, you see the word average, that's y2 minus y1, x2 minus x1. Instantaneous, that's a slope, that's a derivative. Take the derivative, plug it in, okay? Actually, this is a slope as well, but it's an average slope. This is a instantaneous at one point. Does that make sense? Okay, so it's just kind of giving you an overview. These are the types of things you want to have down, and they will help you with the applications. No, into the original function. Yes, we don't even use the derivative. So we use the original, get those y values, and we're getting just a slope of the tangent of the secant line. No calculus involved. It's algebra. So average rate of change, that's an algebra problem. We don't use calculus. Instantaneous, that's the only time we're going to use the derivative. Good question. Okay. Some questions on marginal analysis. So that's what we did on Thursday. What time is it? Oh, we're doing good. All of these are good, but I tried to pick one. If you're going to do one of these, do at least number 4. And again, I suggest you do all of them, but this one's good because they give you a cost function, they give you a revenue function, and then they want you to find the profit function. So how do I get the profit function if I know revenue and cost? Subtract them, right? Revenue minus cost. Good. So revenue's here, here's the cost, so this minus this whole thing. Now remember, when you're minusing the cost function, you're minusing the whole thing. So the negative sign is going to distribute through. That's one of the biggest mistakes I see is not, it's because it's a detailed one. You put everything else together, but when you subtract this, the negative is going to distribute through. Does that make sense? Okay, so R minus C, that'll give you your profit function. And then again, there's a question about what's your profit function. Okay, it gives it. And then they want a marginal profit function. What is a marginal profit function? The derivative of the profit function. So marginals are just the first derivative. Okay, and yes, we can take more than one derivative, but for this we're not doing it now. Okay, so then they want the marginal profit. So once you got the profit, take its derivative, there's your marginal, and then marginal profit if you sell 100 candles. Remember, what is that marginal giving us? It's giving us what our profit would be on the 101 candle. But we plug in 100, it gives us the next one. Okay. So remember, if you're interpreting this is an open-ended answer. Include units, interpret your answers. So on this one, I would say, let's say it's $5, whatever, that when I sell, that I will make an additional $5 when I sell that 101st candle, right? Marginal is the additional profit you make from selling that one more candle. So kind of include that. Okay. Whoa, we're done. That's the test. So, and I made sure that, let's see, what did I do? I marked 1, 2, 3, 4, 5. There's one that I'm going to change. So I've got 5 so far. 6, 7, which actually has 3 questions there, right? So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. These are actually all one question. I just want you to see that. I've lost count. Anyway, about 14. This one's going to be a graphing one, so there's 15. That's about how many questions there are. Again, there's 11 numbered questions, but a few of them have multiple parts. But this will, if you do that, look up the graph one, and let me just direct you to. Come on, here we go. So, and I can go back over that if you didn't get any of those numbers, but let me see if I've got, maybe, did I not put the link in? Sure, why not? I'll add it in here. So in this exam review, I'll put down here highlighted version. So, okay, that's, sure. Good thought. I'll also put a link to the quiz. A number of you found the link and you took it, but those who haven't, I'll put that because it's not showing up, but I will put a link for it right in here, right under this. So there'll be a quiz thing. If you've already taken it, you're fine. If you haven't taken it, again, you get 3 attempts, and it's good study. It's in person, on paper. For the multiple choice, you just have to fill in the A, B, C, D. There's a little portion to fill in on that to make it easy for grading. We'll take it here. I pass out the exams. You take it. There's 2 versions, so you don't know who your neighbor has the same version as you or not. They're very similar, but try to do your own work. Keep your eyes on your own paper, because otherwise you say, oh, they said it was C, but I think it's B. Well, they both might be right. Okay, so yeah, it'll be here. We have the full class period. I haven't noticed any class coming in after us, so as long as that doesn't change, I'll stay, and you can leave when you're done. Yeah, it should only take the 50 minutes because that's what the other classes are, but I'm not going to cut anyone. That's just not my policy. So if you need a little bit of time, you'll have that time. But I think you'll easily be done in 50 minutes, especially if you go through that review. So I'm going to post the highlighted version. What else? I'm going to make the quiz visible right up in the front. Do that. Those are really the only 2 things you need to work on. If you need extensions on any of the homeworks, let me know. I think I will go ahead and move 11.2. I already moved 11.2 and 11.1, didn't I? Till Thursday. I can move them to Monday, but it's better to get all that stuff done now so that you can spend the weekend. But if you need extensions, just let me know. I can extend it. I want you to work on those things. I want you to practice next Tuesday. So it's 1 week. So Tuesday night right here. Yes, I think is that I'm right, right? It's been a long day. Pacing calendar. Let's check to make sure I got this right. I noticed somebody mentioned that it was still showing as Sunday, so I did even change it here that they're due on Tuesdays usually. So yeah, the exam will be next Tuesday here, and then we'll get into 11.3. And I doubled up on one of the units that I think should be short for us. Will be fine. So that's how I picked up a day, and um, I think we're going to see a lot better success without going into 11.3 tonight. And now you know what you need to do. Let's do it. Um, Thursday, I have office hours. I had what 4 or 5 of you maybe in the office hours. So please feel free to come. It's not a requirement, but if you need questions, that's a good place. We just jump around and answer questions. Come Thursday, I have nothing else on the slate except to answer questions. If we've got a few general questions, we can do it as a group, or we can get in small groups. Whatever you need, that's what it's here. If you get through it and you all feel confident, you could take a break, go to bed early or have a party or whatever. So Super Bowl's coming up pretty soon, isn't it? 12th, so I guess it's further down the road. But anyway, just make sure you're going to be successful, feeling confident, comfortable, and let me know what you need.